Hi guys, so today we're talking about three-dimensional figures and we're going to get started with some definitions and stuff that is in the book. Okay, so three-dimensional figures, the first word is polyhedron. A polyhedron is a solid with all flat surfaces that enclose a single region of space. Each of those flat surfaces is a face, and that face is a polygon. Okay, so if the faces aren't polygons, it is not considered a polyhedron. Okay? Um, or each of the sides, like not actually sides, because sides could be edges, but each of the surfaces. Okay. The line segments where the faces intersect are known as edges. Right? So this is an edge of a polyhedron. This is an edge, right? And then edges intersect at a point called the vertex. A prism is a polyhedron with two parallel congruent faces known as bases. Okay, and then the intersection of three edges again is a vertex. A regular prism is a prism where the bases are regular polygons. Okay. A pyramid is a type of polyhedron. It is not a prism though. And what is unique about a pyramid is that all faces intersect at one vertex. Okay. And all of the faces other than the base are also triangles. Okay. A polyhedron is a regular polyhedron, again, if all of its faces are regular congruent polygons and all of the edges are congruent. Okay. So here are some examples of prisms and pyramids. Okay. This is a triangular prism because the base is a triangle. Note the base does not have to be on the bottom. For a prism, the bases are just the sides that are parallel and congruent to each other. Okay, and so in this case, it's a triangle. This is a rectangular prism. This is a pentagonal prism because the bases, the parallel congruent sides are pentagons. This is a pyramid. Pyramids are also named by the bases, and since the base here is a square, it's a square pyramid. Okay. On the next page, it has some things about Platonic solids. Platonic solids are our five regular polyhedra. The reason why they're called Platonic solids is because they're named after Plato, who wrote about them a lot in his writings. Okay. These are the five Platonic solids. This is a tetrahedron. It has four faces, and all of the faces are equilateral triangles. Right. This is a hexahedron, also known as a cube. That's probably the most common Platonic solid. It has six faces. It's a square. Right? So each of these are named by how many faces they have. Right? So tetra for four, hex for six. Octahedron has 8 faces. They are all equilateral triangles. The dodecahedron has 12 faces. That's why it's dodeca, and these are all pentagons. And then the last one here is our icosahedron, which has 20 sides, and they're all equilateral triangles. Okay. These are not polyhedrons because they're not composed. Their faces are not composed of polygons. Instead, they're curved. So that is our cylinder, our cone, and our sphere. Okay. So first thing we're going to do is identify the solid. Okay. We're going to name the base, faces, edges, and vertices. I'm going to save some time. I'm not going to write them, so I'm going to actually use our book. Okay. So the first one here is a pyramid. Okay. We do not know that all of the sides of the base, the bottom, are congruent, so we can just say that they're rectangular. Okay. So this is a rectangular pyramid. Okay. The base is rectangle ABCD. It's just on the bottom. Okay. It has 5 faces. It has the base on the bottom, ABCD. It has triangle AED, which is facing us in front. It has triangle DEC, which is this right side here. Triangle CEB, which is the back side of the pyramid. And triangle AEB, which is this left side. Okay. Edges are all of the lines that are creating this pyramid. And so we have AB, BC, CD, and DA. We have AE here, DE, CE, and then the back one is BE. Right? And then vertices are pointy ends are A, B, C, D, and E. Okay? For B here, this is a triangular prism. Note that even though the bottom is a rectangle, prisms are named by its bases, which are the parallel and congruent sides. So in that case, that is this and this. Okay. So the basis is triangle IJK here and triangle LMN here. Okay. So here are our faces. We have our two bases, IJK and LMN, and then our rectangles. So the bottom one here, ILNK, KJMN is the slanted one here, and then rectangle IJML is this face here. Okay. Edges are each of our lines that form this shape or figure. So we have IL, LN, NK, and IK. We have IJ and LM, the vertical parts. And then we have a JM, the horizontal part here. We have MN, the slanted one, and JK, which is the slanted one here. Okay. And then the vertices are our corner pieces, which is I, J, K, L, M, and N. Okay. The last one here, this should be a cone. Okay. The base is circle K, and it only has one vertex, which is up here at point P. Okay. Okay, so there you go. You're going to be doing check your progress 1A and 1B, and then checking your answer once you're done. Okay, so 1A is a cylinder. It has base of circle R and circle T. It doesn't have any vertices, edges, vertex, stuff like that. Okay. 1B is our triangular prism. Okay. Your order of letters might be different. Remember how we name polygons is you just pick one of your vertices and then you just go in order. Okay. So for me, I picked the triangle GHI. Again, if you call it HIG, if you want the other way, that's fine. You just need to go in order. Okay. So my basis is triangle GHI here and triangle JKL. So the faces include those two bases as well as HKJG, which is this left side here, HKLI, which is this right side, and then rectangle JLIG, which is the bottom part. Okay. The edges, or the lines forming it, is GH, HIIG, KL, LJ, and JK, those form the triangles, and then the parts that connect the triangles are HK, IL, and GJ. Okay. The vertices or corners are points H, I, G, J, K, and L. Okay. Okay. The next part is on surface area and volume. Okay, so here in your book, you have a description of surface area. Surface area is the sum of the area of each face of a solid, and volume is the measure of the amount of space, the 3D space the solid encloses. Okay. Here you have formulas for it. I personally don't use formulas when it comes to surface area. I just use the definition of surface area to normally find surface area. Especially later on in the book when we do more complex surface areas, the formula has its limitations when you have more irregular shapes. Okay. The volume formula, though, I would have it memorized because that's quite common. Okay. But that's all for you on page 62. Okay. So let's get started with example 2 on surface area and volume. Okay. So here we're going to find the surface area of the square pyramid. Like I said, I don't use the formula for it because it's not as useful once you have more complex shapes. Okay, so surface area definitionally is just the sum of all of the areas of your surface. Some of the areas of all your surfaces. Yeah. So here with our square pyramid, you should see that the face is the base, which is the square, and then the 4 triangles that connected to the vertex. Okay, so I'm going to do SA for surface area. Okay, the first one I'm going to do is my square. Since the base is a square, the sides are all the same. So that's 6 times 6. Okay, so here, this is my square. Okay. Since the bottom is a square, that means each of these triangles are going to be congruent to each other. Okay. So this is, I'm going to do 4 of them since there's 4 of them here. And then area of a triangle is 1/2 base of the triangle, which in this case is 6. And then the height of the triangle, note the height of this triangle is not the height of the pyramid. Okay, it's not the same. Instead, it's the slant height, which is 5 centimeters. Okay. So here, it's this one. Okay. So if you want an explanation here, okay, sorry. This is the area of the square, 6 times 6. Okay. This is here is because there's 4 of these exact same triangles. I can only do that because they're all the same. And then here, this, if only my blue pen was working, is the area of a triangle, which is 1/2 base times height. Okay. And so that's where that all comes from. Okay. Then I'm going to do the math. So 6 times 6 is 36. Okay. 4 times 1/2, half of 4 is 2. And then 6 times 5 is 30. So 30 times 2 is 60. So 36 plus 6 is 96. And since my units is centimeters, this is going to be centimeters squared because it is area. Okay, so that is my surface area. Okay. Then I'm going to do volume of a pyramid. Volume of a pyramid is 1/3 area of base times the height. Okay. So volume is 1/3 area of base, which is 6 times 6. And then the height of the pyramid, which is 4. Okay. So if you're wondering what all the parts are, okay, this is the area of base. And this here is the height of the pyramid. Okay. Which you will see is the formula. 1/3, capital B is area of the base, and then H is height. Okay. Let's do the math. So 1/3 of 6 is 2. 2 times 6 is 12. 12 times 4 is 48. Okay. And then here, since this is centimeters times centimeters times centimeters, the units for volume is centimeters cubed. And there you go. Okay. You're going to do CYP2 and then come check your answer once you're done. Okay. You should have gotten a surface area of 360 centimeters square and a volume of 400 centimeters cubed. If you got that right, move on to example 3. If not, here's your explanation. Okay. So the drawing of this, if you chose to draw it, should look pretty similar to the one before. The only difference is now the measurements have changed. Okay. So it's pretty similar. Okay. So surface area, the base, since the base has dimensions of 10 centimeters, it's 10 times 10 for that square part, right? And then here, because it's square, all of those triangles are going to be the same because the base lengths are the same here. So instead of doing it 4 times, I'm just saying there's 4 of these triangles. And then the area formula for a triangle is 1/2 base height, 1/2. The base of the triangle now has a length of 10 centimeters, and the height is going to be that slanted height because the triangle isn't just straight up and down, it's slanted to form the pyramid. That slant height is 13. Okay. 10 times 10 is 100. 4 times 1/2 is 2. 2 times 10 is 20. 20 times 13 is that 260. 100 plus 260 gives you your 360 centimeters squared. Your volume for your square pyramid is 1/3 area of base times the height of the pyramid. Your base is a square, so that's why it's 10 times 10 here. And then the height of your pyramid is 12 centimeters. Okay? So the way I did this is a third of 12 is 4. Your 10 times 10 is 100. 100 times 4 is 400. So 400 centimeters cubed. Okay? Now to our last example, also on surface area and volume. Okay? So here we have a pool. Pictures here. The diameter of the pool is 8 feet and the height of the pool is 20 inches. We want to know what is the surface area of the pool. Okay, so one thing to recognize is that the measurements unit is not the same, right? It gave us the diameter in feet, but it gave us the height in inches. So what we're going to do first is we're going to convert that inches into feet as well. Okay, and so 20 inches right, is 1 feet and 8 inches. Okay. What we know is that there's 12 inches in a foot, so that's 1 and 8 over 12, which becomes 1 and 2/3 feet. And so we're going to be using that 1 and 2/3 feet for this height. Okay. So it's going to ask for surface area of the pool. Okay. So surface area of the pool. Wait. All right. So here, we're gonna do our two cylinders. Our two circles, as well as the wraparound. Okay. So the wraparound is related to the circumference, so that's why in the formula you see that 2 pi r. Okay. So 2 pi, the radius, if this is 8 feet, the radius is 4 feet, so 2 pi, 4 feet. And then the height, we're going to make it the same units, so that's why we're going to change it with our feet, 1 and 2/3 feet. Okay. Plus, we have our two circles. Okay, so that is 2 pi r squared. 2 pi r squared because we have two of them. We have the top and the bottom. However, since it just wants the one base, not the top one, right, because there's no covering on our pool, it's just going to be pi r squared. Versus if you look at the formula on your book, it has the 2 pi if it included the top and the bottom of the cylinder. But since this pool, we don't want the top, we're just going to do pi r squared. So pi 4 feet squared. Okay. We're gonna type it in. Okay. And this gives us approximately 92.2 feet squared. So this is our surface area. 92.2 square feet. Okay. In part B, it asks us if he fills the pool with water to a depth of 16 inches rather than that whole height of 20 inches, what is the volume of water in the pool in cubic feet, round to the nearest 10? Okay. So for volume, V equals pi r squared h. Okay. So again, we're going to convert our 16 inches into feet. Okay. So 16 inches, we know, is 1 feet and 4 inches, because there's 12 inches in a foot. Okay. And then with that, since there's 4 inches in a foot, that'll be 4/12 of a feet, which is 1 and 1/3 feet. Okay. So this is the height we're going to be using. Okay. So volume equals pi. Our radius we talked about earlier, since the diameter is 8 feet, the radius is 4. Then the height we got is 1 and 1/3. Okay. Type that all into the calculator. It wants us to round to the nearest tenth, so that's about 67.0. Feet squared, so feet times feet is feet squared, times feet again would be feet cubed, which is why volume is units cubed. So the volume is 67.0 feet cubed. Okay. You're going to try number 3 on your own and then come check your work. Okay, the answer is 6 inches cubed. If you got it, you can get started on homework. If not, here is your explanation. Okay. So here I kind of drew a picture of it. We have a square pyramid. Yeah, the measure of each side of the base is 2 inches, so it's 2 inches here. And then the height of the pyramid is 4.5 inches. It asks us for the volume. Volume for a pyramid is 1/3 area of base times the height of the pyramid. Since it's a square, it's just the sides squared, so 2 inches times 2 inches. And the height of pyramid, it told me, was 4.5 inches. Then I multiplied them all together, and that gave me 6 inches cubed. Okay. That's it for today. Have a great rest of the day. Bye, guys.